So for this problem, we have the mass of a substance, which follows a continuous exponential growth model, is being studied in a lab. The doubling time for this substance was observed to be 16 hours. There were 86.9 milligrams of the substance present at the beginning of the study. Okay, so for our question, we have let T be the time in hours since the beginning of the study, and let Y be the amount of the substance at time T. Write a formula relating Y to T. Use exact expressions to fill in the missing parts of the formula, and do not use approximations. Okay, so the first thing I'm going to do is I'm going to look at the continuous exponential growth model, and that is Y equals Y sub 0 e raised to the power of R times T, or actually, it's K times T, where Y equals the final amount, Y sub 0 equals the initial amount, E raised to the power of K, which is the rate, and T, which is the time. So the first thing we're going to do is we're going to fill in what we know in this exponential growth equation right here. So we know that there were 86.9 milligrams of a substance present at the beginning of the study. So Y sub 0 is equal to 86.9. We also know that the doubling time for this substance was observed to be 16 hours. So we know that Y equals, the time is 16 hours. And we also know that the doubling time of the substance was observed to be 16 hours. So we know that our final amount, our Y, is equal to 2 times our initial amount, our 86.9. So we can write this equation as 2 times 86.9 equals 86.9 e raised to the power of k times 16. 16 is hours in this case. So now what we can do is we can cancel out 86.9. So now we have 2 equals e to the power of k times 16. Now we're going to take the natural log on both sides. So we have the natural log of 2 equals the natural log of e times k to the 16. Or, I'm sorry, raised to the power of k times 16. Because ln e is equal to 1, we can rewrite this expression as ln2 equals, and just bring down this k times 16. Now we're going to solve for k. So we get ln2 over 16 equals k. All we did was just divide by 16 on both sides, by the way. Okay, so now to get this equation right here, it will be, let me write this in another color, y equals the initial amount, which was 86.9, e times, or raised to the power of ln, the natural log of 2 over 16 times t. So in this little bubble, I don't think I'd be able to write it in there, but so this is equal to this. And that is the answer to this problem.